As we move to the back side of this lesson, we're going to look at some special cases, in particular inscribed angles and how they can be useful to solve some problems. One of the things we can always notice is when we have two angles that are inscribed on the same arc, these both are across from this arc, the angles have to be the same because they both have to be half of what a sector angle would be. So that allows us to solve some problems. And the second one is if we have a diameter all the way through the center inscribed in an arc, well, its inscribed angle, the one at the back there, always turns out to be 90 degrees, and it must be because you have half of a circle as your diameter there, 180 degrees. Knowing those two things, you can solve some problems. You might want to work ahead, try some of the examples before I take them up. If you're not so sure about things, come back, check in. Okay, but we'll take you through some of these examples here. This first one, I want to find x. Okay, x is inscribed in this arc. Well, if I look at the 45, it's inscribed in the same arc. It tells me that x has to be 45. If I flip that circle over and look at the y, and y is inscribed on this arc right here, well, that angle is inscribed in the same arc, so y has to be 30 degrees. Looking at B, I'm seeing a sector angle there, the 90. I'm looking at A and B. I notice all three of these are inscribed in the same arc. They're all across from that one. And because 90 is a sector angle and A and B are both inscribed angles and they're both equal to each other, they both have to be half of that 90, or in other words, they have to be 45 degrees each. In C, if I go to try and solve for x, first of all, I look at x and I don't see an inscribed angle. I don't see a sector angle. In fact, I see something that I know from previous, one of the basic rules. Right? X and 70 together make a straight line. And we know straight lines add up to 180. So if I take 180 and I subtract the 70, x has to be 110. And so don't fall for the trap where everything has to be inscribed or sectors. Sometimes you have some of those old basic rules as well. To solve for y, I'm looking for an inscribed angle this time though, because I have some chords, and they're inscribed on that arc. And if I can find something else inscribed in that arc, namely the 40, I can figure out what y is. And letter D, I see a dot in the middle as the center, which means I got a sector angle right here. Okay, it's inscribed on that arc, as is the y, and as is the x. So x and y have to be the same. They're both inscribed on the same angle, and they're both half of a sector angle, half of 35. So they each have to be 17.5 degrees. Let's move to the last two examples. Give them a try, see what you can do. I look at this and I say to myself, hey, I've got a diameter, which means that the angle inscribed on the same arc, the one across from there, has to be a 90. Which is kind of handy because when I have this triangle right here, I know triangles add up to 180 degrees. So y in this case, has to be 180 minus the 65 minus the 90 we just figured out, leaving me with 25 degrees for y. And because I know that, I can now solve for x. Okay? X is inscribed on this arc right here at the bottom. Well, so is the y, right? So both those have to be the same. So x also has to be 25 degrees. If we look at the last one, I see a sector angle again right here, right? We got this sector. And because x is inscribed in the same arc, we know x will be half of that sector angle. So if I can figure what the angle is right here, I can figure out what half of that would be to figure what x would be. So what can I do to figure out that angle there? Well, here's something kind of interesting. This is a radius, and so is this, which means they're both the same size. If they're both the same size, two sides the same, I have an isosceles triangle. The nice thing about isosceles triangles, two sides the same, two angles the same, namely the ones that are across from the equal sides. So that angle there has to be a 50, which means the one at the top up here, the one I really wanted, taking the idea of a triangle, 180, that's what all the angles add up to, minus the two 50s, leaves me with 80 degrees. That's my sector angle, which means x has to be half of that. It's the inscribed angle, which means it has to be 40 degrees. And that takes us through angles and circles. The homework today is just a handout. Try some of the questions on it, the answers on the back, and when you got that figured out, give the quiz a try. Yes.